Hello students, welcome back. We're going to be working on solving exponential equations today. And so before we do that, I'm going to do a quick review of exponent rules, and I'll have you refer to the base chart that is included with your Google Classroom information. So just a few exponent rules. The first is any base to a zero power is 1. So doesn't keep the base, it just becomes the number 1. If you have a base to a negative exponent, then that makes the base be the reciprocal. So the reciprocal of the base means that the b in this problem would go to the denominator, and then the exponent would become a positive. So 1 over b to the first would be equal to b to the negative 1. B to the negative 2 would be 1 over b to the positive 2 power. So again, the base goes to the denominator and the exponent becomes positive. Then we'll review some exponent properties. If you're multiplying with the same bases, you keep the base and add the exponents. So again, multiplying, add the exponents. If you are taking a power to another power, then you keep the base and multiply those exponents. So when you see a power outside of a parentheses like that, multiply the exponents. And then if you're dividing the base and it has exponents, you keep the base and subtract top to bottom. So subtract those exponents. And then I have a little note here. This is just to show you that these rules only apply if the bases are the same. In this case, the 2 and the 3, those bases are different, so you would not be able to add the exponents. And then something we haven't worked with quite as much, if you have a fraction exponent, that will change to a radical. So b to the 1/2 would be a square root. The numerator becomes the exponent inside. So this would become b to the first, and the denominator becomes the index. Now the index goes in the hook of the root. We don't normally write the square on the square root, but that's where it would go. So one like this, if you have b to the 5/7, inside the radical sign would be b to the 5th power, and then the 7 is the index. It's the 7th root. That's how you would say that. The 7th root of b to the 5th power. So that's just a little bit about exponents and their rules. And so we'll look at how to use these rules and solve exponential equations. So the big thing about exponential equations is that you get each side of the equation equal to the same base, and then you'll drop the bases and set the exponents equal to each other, and then solve the equation that results. So this first problem, we have 7 to the 6x equaling 7 to the 2x minus 20. So this base is 7 on each side. You can cancel those out and then just work with your exponents. So 6x on the one side equals, and then on the right-hand side, 2x minus 20, and then we just solve this equation. So we can subtract 2x from both sides, 4x would equal negative 20. Then dividing by 4, we get x equals negative 5. So notice that the variable that we solved for was the exponent. So this is a new type of equation where you're solving for the exponent. Now, in this one, we have 5 to the 2x equals 125. So if you will look at your base chart, which I'll pull up for us now. Let me go back to the notes. You'll want to notice that the bases are not the same. So right here, these bases are not the same. Let me get back here. We have the 5 and then we have the 125. So we can go to our base chart. And in this base chart, I can look to see, is the 125 in the 5 row? And it is. So I can change 125 to 5 to the 3rd power. And so that's what I'll be working on here. So as I switch back to this, I'll have 5 to the 2x power equals 5, and it was to the 3rd power. And now my bases are the same. And I can cancel those bases now and then set my exponents equal to each other. So 2x would equal 3. I'll divide both sides by 2 and get x equals 3/2. If you get a fraction, go ahead and leave it that way. So that's solving for the exponent, where we first of all had to make the right-hand base equal to the left-hand. As we move on and consider number 3, I have 9 and I have 27. So those two bases are not the same. And when I look at my base chart, 9 is not in the same row as 27. So I'm going to have to find a different row that has both those numbers in it. And if you think about 9, 9 has 3 as a factor. So is 9 in the same row as 27 for row 3? And it is. So we can change 9 into 3 to the 2nd power. We can change 27 into 3 to the 3rd power. So we'll go back to the notes again. And we have 9, which I'm going to change to 3 to the 2nd power. But notice that I already had a power there. So I'm going to go ahead and write that beside my 2. I'll be multiplying these exponents. Then I have equals. For 27, I have 3. It was to the 3rd power, but I already had a y. So I'll multiply that y by the 3. So now I can cancel the bases. I now have them the same, but my exponents now are what I'll be working with. So I'm going to take 2 times the 2y minus 1, set that equal to my other exponent, 3y, and then solve this equation. I'll have to distribute, so 4y minus, I'll distribute and get 2. That equals 3y. I can subtract 4y from both sides of the equal sign, and I get negative 2 equals negative 1y. Can divide both sides by negative 1, and my y turns out to be 2. So I get 2 for an answer for that. And then finally, I have the fraction 1/9 and 81. So I need to look to see what row 1/9 and 81 would be in. And actually, you could do this in two ways. 1/9 and 81 are both in row 3. They actually are also both in row 9. 1/9 is here, 81 is here. So you can use either the 9 row or the 3 row. I'm going to go ahead and use the 3. So 1/9 can be written as 3. This will be a negative exponent because it's a fraction. So 3 to the negative 2 power. 81 can be rewritten as 3 to the 4th power. So here we go with those rewrites. 1/9 was 3 to the negative 2 power. And I already have an m there. So I'm going to write that m. And then equals 81, which was 3. Oops. So that was 3 to the 4th power. And then I already had an m plus 4. So that will multiply by this 4. So my bases are the same. I can cancel those, set my exponents equal to each other to be solved. So negative 2m would equal 4 times the m plus 4. And so negative 2m would equal 4m plus, and then 4 times 4, 16. I'll subtract 4m to each side. That gives me negative 6m equals 16. Dividing both sides by negative 6, I get m equals negative 16 over 6, and I can divide 2 into both of those, or you can type it into Desmos and let it reduce for you, but that reduces to negative 8 over 3. So those are the type of problems that you'll have for solving exponential equations, and your homework will be a Math Excel assignment. Good luck on your homework.